Hey Justin, this is Mr. Ronquillo. Okay, so I took a look at what you did for the remediation. Okay, so you're good with page 1. You need to kind of refine and fix some of the things for the other pages that you submitted. Okay, so here I'm going to go through a few examples from each page, few types of examples. Now, these aren't the exact problems from the page, right? But I gave some very similar examples here that hopefully, again, you can watch this video as many times as you need to be able to figure out how to answer these questions. Okay, so on page 5, you were given graphs of lines, and you're asked to identify the x and the y intercept. Okay, so identifying the x and the y intercept. So again, if you recall, we talked about in class, the x-intercept is where the line hits the x-axis, and the y-intercept is the point where the line hits the y-axis. Okay, so when you are writing out the answer for x and y-intercept, so here we see the y-intercept is at 2 on the y-axis. So again, when you write that out, right, y-intercept, write it as an ordered pair. Alright, so we're looking for the y-intercept, so the ordered pair for this point is at 0, 2. Okay, so that's for the y-intercept. Here, the x-intercept, we see it crosses the x-axis at -3. Alright, so the x-intercept is at -3, 0. That's the ordered pair for the x-intercept. Okay, so do one more time here with this line. Here's the y-intercept. That's where it hits the y-axis at 1, 2, 3, 4. Okay, so now again, I noticed that you did write as an ordered pair, but you're pairing up the x numbers and the y numbers as one ordered pair, right? We need 2 separate ordered pairs for each of these intercepts. So again, here it crosses the y-axis at 4. So the y-intercept is at 0, 4, right? The x number is 0. The y number for the ordered pair is 4. Here it crosses the x-axis at 1. Okay, so the x-intercept is at 1, 0. The x number is 1. The y number is 0. Okay, so that's how you should write the answers for x and y intercept for problems on page 5. Alright, so then later on you're given equations, right? You're not given any graphs. And then you're asked to identify the x and the y intercepts. Okay, so instead of changing these into y equals mx plus b, right, or making a table, right, what you can do to find the x and y intercepts is this. Right, we know that for the y-intercept, the x number is 0, right? For the y-intercept, the x value is 0. So to find the y-intercept, we're going to plug 0 in for x. Now, when you plug 0 here in for x and you multiply by 2, what happens is that kind of goes away. So we talked about in class, it's kind of like what's called the cover-up method, right? Again, we plug 0 in for x. That whole thing goes away. So now you're left with this part of the equation, -4y equals 12. Solving for y, you get y is equal to -3. Right? You divide both sides by -4, and you get y is equal to -3. So therefore, we found the y-intercept. Remember, we plugged 0 in for x, right? So there's the x number. Plug 0 in for x. That goes away. We solve for y. Y is equal to -3. So there's our y-intercept. To find the x-intercept, we're going to plug 0 in for y, right? So here's our x, there's our y. Plug 0 in for y. What happens, right? This part goes away. So now you're left with 2x equals 12. Solving for x, x is equal to 6. So here we have the x-intercept is at 6, 0. Okay, do that again here with this next example. Here we want to find the y-intercept. So to find the y-intercept, we're going to make of our x and our y. For our ordered pair, we're going to make x 0. So we plug 0 in for x. 5 times 0 is 0, so that goes away. Solving for y, y has to be equal to negative 10. So there's our y-intercept, 0, negative 10. X-intercept of the x and the y is 0. So we plug 0 in for y. 2 times 0 is 0, so that goes away. We cover that up. We have 5x equals negative 20. Solving for x, we get x is equal to negative 4. So there's our x-intercept. Okay. Alright, now moving on to pages 9 and 11, where you're asked to make a table and then graph. So again, for these, when you're making a table, it's just like any other table that we've done in class. Right? You're going to pick some x numbers, it's going to generate some y values, and then you plot those ordered pairs. Right? So again, let's pick some negatives. So I'll pick like a negative 2 and negative 1. I'll pick a 0 and some positive numbers for x. Plug negative 2 in for x. 2 times negative 2 is negative 4. Minus 5 is negative 9. Plug negative 1 in for x. 2 times negative 1 is negative 2. Minus 5 is negative 7. 0 in for x. 2 times 0 is 0. Minus 5 is negative 5. 1 in for x. 2 times 1 is 2. Minus 5 is negative 3. And finally, plug 2 in for x. 2 times 2 is 4. 4 minus 5 is negative 1. Okay. So then you go to your graph grid. So I'm going to make a little makeshift graph grid here. Alright, so we got our x values, 1, 2, and our y values are all negative. So we got negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so negative 2, negative 9, negative 1, negative 7, 0, negative 5, 3, and then 2, negative 1. Okay, so you graph those points. Alright, so they're going to graph a line, since we have the or equal to option here, so we know this line is going to be solid. I'm just doing this freehand here. Alright, so there's our solid line. And again, you did a good job with the shading, so you got to figure out which side to shade. And we're going to test. You can plug 0, 0 here, and here's a test point, 0, 0. You plug 0 in for x and 0 in for y. We're going to test this point. Right, see if it works for this inequality. So we're going to plug 0 in for y, 0 in for x. So now again, this is not coming from our table, right? This is us picking a point on either side of this line. So I pick 0, 0, do the math, 0 minus 5. Alright, so I'm left with this statement, 0 is less than negative 5, and that's not true. Alright, because this test point does not work, that means everything on this side works, so we're going to shade this side of the line. Okay, so now, this next one, I gave you one with a fraction. Okay, so again, remember when we're making these tables for x and y, for graphing, we can pick any x numbers that we want. So now because this is a fraction, we just don't want to pick the standard negative 2, negative 1, 0, 1, 2 numbers, because that's just going to give us fractions, and we all know how much we don't like fractions in math, right? So what we want to do, because this denominator is a 3, right, we want to pick x values that are multiples of 3, right? Because that's what's going to happen here is this 3 is going to cancel, so we don't have to deal with fractions. Right? Like, for example, if I picked negative 6. Right? If I plugged in negative 6 here, 2/3 times negative 6. Right? So I do the math here. Right? 2/3 times negative 6. This 3 and this negative 6 is going to cancel. That's going to reduce that to negative 2. So now I have 2 times negative 2 is negative 4. plus 1 is negative 3. Right? Again, we don't have to deal with messy fractions. Let me pick negative 3 as my x number. Plug negative 3 in for x. 3 in is negative 3, reduce this down to negative 1. 2 times negative 1 is negative 2, plus 1 is negative 1. Right? 0 is nice. Right? 2/3 times 0 is 0, plus 1 is 1. Again, I don't want to pick 1 or 2 because that's not going to get this denominator to cancel, and I'm going to be stuck with fractions. So instead, I'm going to pick 3. Right? Plug 3 in for x. This 3 and this 3 cancel. 2 times 1 is 2, plus 1 is 3. Right? Nice numbers to graph. Alright, now for these last two examples, it's kind of a combination of what we've been going over here. Right, so, sorry, let me fix this here. Let's move 12y. Alright, so again, we want to graph this inequality. Right? Now, we don't necessarily have to make a full table, right, because we're looking at the numbers and we're thinking, hey, let's just go ahead and graph x and y intercepts. Okay, so let's first find the y-intercept for this. So again, remember, when we find the y-intercept, we're going to plug 0 in for x. 0 in for x, so that goes away. So I'm left with 12y and a 24, so y has to equal 2. So there's my y-intercept. For my x-intercept, I'm going to plug of my x and or y, I'm going to plug 0 in for y, so 0 in here. 12 times 0 is 0, so that goes away. So I'm left with 3x, there's 24, x has to equal 8. Alright, so now when I go to my graph grid, I'm going to find my x-intercept of 8. 1, 2, 3, 4, 5, 6, 7, 8, put a dot. My y-intercept of 2, 1, 2, put a dot. Now we can graph our line. Right? Because I don't have an or equal to here, this line is going to be dashed. Okay, so we can't forget whether our line is going to be dashed or solid. Alright, now I got to figure out what side to shade. So again, I'm going to test 0, 0, because 0, 0 is right here. This is my test point. Plug 0 in for x, 0 in for y. And basically it's 0 plus 0, which is 0, which is less than 24. That's true. So I'm going to shade on this side of the line. Alright, for this last example, again, we're going to just find intercepts. So we got a y-intercept. Alright, we're plugging 0 in for x. It's going to get rid of this part. So now I'm left with negative y equals negative 8. So what does y have to equal? 8. Find our x-intercept. Plug 0 in for y. So plug 0 in here. That goes away. So now I'm left with 4x and a negative 8. So x has to be equal to negative 2. There's our x-intercept. So we go to our graph grid. Y-intercept, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. X-intercept, negative 2. Put a dot. Connect it with the dashed line. And you figure out what side to shade, right? Test 0, 0. Plug 0 and 0 in for x and y. I'm left with 0 is greater than negative 8. And that's true. So that's the side we shade. Alright, so hopefully that helped you a little bit. So go back and do those pages 5, 9, and 11, and page 15 again. Make the revisions, send them back to me, and then hopefully we can move on from there. Alright, so again, if you have any questions, Justin, just let me know. Alright.